All right, Matthew, here we go. We got lesson 9.1.2, parabola investigation. All right, so the function f of x equals x to the second here. This is what we call the parent function for a quadratic function. That just means that it's the most basic form of a quadratic equation. All right, so here we have the actual equation here. This is f of x equals x to the second. We're just going to answer these questions to it. Find the vertex. That's the easy part right there. There's our vertex right down there at 0, 0. So that's going to be our vertex. What's the axis of symmetry? Remember, the axis of symmetry is that line that goes right down the middle that splits it up into a mirror image of itself. So our axis of symmetry is right here. This is the y-axis. Now, the equation for the y-axis is x equals 0, because anything on the y-axis, the x value in an ordered pair would be 0. So like this is the point 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So every time that we have a point there, the x value is 0. All right, when x is 1, what's the value of y? So 1, 1. So there's 1, 1. There's the value of y there. So the value of y is 1. What about when x is 2? Well, when x is 2, so we go over 2. 1, 2, 3, 4. So the value of y would be 4. What about negative 3? If we go back 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, looks like right there. So positive 9. The y values can never be what? Well, the y values can never be negative because our minimum value, our lowest point here at a vertex is 0, 0. So we're never going to get a negative value. How does an increase or decrease in the x value affect the y value? So if I start here at my vertex and I increase my x value by 1, my y value increases by 1. But if I increase my x value by 2, my y value doesn't increase by 2, it increases by 4 instead. So basically, each increase of your x value is squared when you look at your y value. So if I increase by 1, 1 squared is 1, so it goes up 1. If I go over 2, that's an increase of 2, so if I square that number, I get 4. If I increase 3, if I square that number, I get 9 up here. So an increase in the x is squared in the y value. So the increase or decrease of x is squared for the y value. All right, next thing, 9-13. For each of the following situations, create a quadratic equation and graph the parabola. Use Desmos.com graphing calculator to help you as you now investigate the parabolas. Okay, so over here on Desmos, I've already got typed in y equals x squared. So there's the parent function right there. Okay, so going back to here, we need to create a quadratic equation that is narrower than the parent function. All right, so I want to narrow that graph. I want to make that like thinner. So if I put a number in front of the x squared right there, like a 2, see how that became smaller? Or if I put 3, see it's getting more and more narrow. But if I put 4, even more narrow. 5, even more narrow, and so on and so forth. So when that value over there is 1, so when you don't see a number there, there's the parent function. But if you make it 2 instead, you see that that pulls it tighter together. I kind of call that number in front of the x squared the strength of, stupid thing. I call that like my strength of my parabola. Like how strong is it to pull in those two sides? So the stronger it is, the more it pulls those two sides of the parabola together. So our bigger numbers are going to pull that together. So let's go ahead and answer this question here. All right, so the equation that we made was f of x equals 2x squared. Now this did not change the vertex. It's still at 0, 0. But now when we move over 1, instead of going up 1, we actually went up 2 instead. And then when we go over 2, instead of going up 4, we'd actually go up 8 instead. 1, 2, 3, 4, 5, 6, 7. I'm off the graph, but close enough. All right, so this is what our new function would end up looking like. Did you see that? That was freehand. Freehand. It looked that beautiful. Got some skills. All right, explain what you do to the parent function to make a narrow parabola. Well, we have a coefficient in front of the x squared, and we make the coefficient bigger than 1. All right, next one. Create a quadratic function that is wider. Okay, so we want to spread it apart for this one. So let's go back to our parent function here. So here's where we changed it. So we were putting in 2, 3, 4, and it got narrower and narrower. So we need to go smaller. So maybe we put over here, 1/2. There you go, it just got wider. 1/3, even wider. 1/4, even wider. 1/5, even wider. So the bigger the denominator that we make here, the wider it becomes. So basically the smaller numbers are going to make it get wider. So let's just keep this at 2 right there. So we can see here that when we move over 1 and go up here, this point right here becomes 0.5. So I go over 1, instead of going up 1, I only go up 1/2 for that one. Okay, so let's go back over here. So we made the equation f of x equals 1/2 x squared. So when we graphed it, that did not change the vertex. It's still at 0, 0. But when we went over 1, we only went up 1/2 instead of 1. We went back 1, 1/2. When we go over 2, instead of going up 4 like we do on the parent function, we go half of that. 1, 2. So 2. Now, if we went over 3 on the parent function, we would go up 9 because we'd square it. But then this one has a 1/2 in front of it. So instead of going up 9, we'd go up half of 9, which is 4.5. I got it. Stupid thing. All right, so this is 1, 2, 3, 4.5. And 4.5 over here, and there's our new function. So it's wider than the parent function. Freehand killing it. That's beautiful. Look at that. So we can see that that's wider than the parent function. So when the number is less than 1 in front of x squared, the coefficient, we're going to get a wider graph, because it has less strength, it can't pull them together. And then when we get a number bigger than 1, here we're seeing that it makes a narrower graph. So what can you do to make it a wider? Make the coefficient of x squared less than 1. Basically make it a fraction. All right, let's do some more stuff. Next, create a quadratic equation that faces down instead of facing up. So the parent function that we have over here. So if I want, this is facing up right now. If I want to face it down, we make it negative. And now we've got our function facing down. Now it's still, like when I go over 1, I normally would have gone up 1 on the parent function. This is killing me. All right, so I go over 1, and then I would have gone up 1, but now I go in the opposite direction. I go down 1. If I go over 2, I'd usually go up 4, because remember we're squaring, but now I'm going down 4. So I'm just going in the opposite direction when that happens. All right, so we decided on the equation f of x equals negative x squared. Didn't change the vertex. And now instead of, when we go over 1, instead of going up 1, we go down 1. When we go over 2, instead of going up 4, we go down 1, 2, 3, 4. And there is our new parabola, and this one now is facing down. That wasn't as good. I was getting cocky. I'm sorry. So what do we need to do to the parent function to make it face down? The coefficient of x squared has to be negative. Next, now we want to shift or translate the function 5 units down. So I want to take the parent function and move it 5 units down. So looking at this, let's go back to the parent function here. I want to move this so that the vertex is right down here at negative 5. So let's see. If I put minus 5 right here, there it goes. It shifted everything down 5. Now from this vertex, if I move over 1, I still go up 1. It's like I just shifted down the floor of the entire thing. We're still going over 1, up 1, over 2, up 4. See right there? We got that point. So I've just shifted the whole parent function down 5 units to get it there. So if we put a negative number out there, and then that kind of means that if I wanted to shift it up instead, I would have probably put a plus 5 over there instead. Let's go back to this. So we came up with f of x equals x squared minus 5. Shifts it down 5. So this finally moves the vertex. And it moves it down 1, 2, 3, 4, 5. There's the new vertex. And if I go over 1, I go up 1. If I go over 2, I go up 1, 2, 3, 4. Because remember, we're still squaring those numbers. And if I go over 3, I'd go up 9. All right, so there's our new parabola. Oh, I'm a wizard. Look at that. All right, so to move a parabola down, the parent function down, it looks like we just need to subtract a number from the x squared. And if we wanted to move it up instead, we'd add a number to the x squared. And now the fun part. How are we going to make it? Now we've got up and down, how to move up and down. Now we've got to move it left and right. All right, so if I want to go 3 units to the right. Now in class, we would have played around with a little bit more of this before. But what we basically need to do here is put in a parenthesis. Let's say plus 1 over here and then square it. All right, so if I have plus 1 here, I actually didn't move it to the right. And I would have thought if I add a number, it should go this way, but it does the opposite of that. So let's subtract 1. Okay, that did move it. So subtracting 1 moves it 1 unit to the right. So if I want to move it 3 units to the right, I would subtract 3, and there it is. I've now moved the vertex 3 units to the right there. All right, let's write this down. So we did f of x equals x minus 3. So it kind of goes the opposite direction that we thought it would have been, and that moves it 1, 2, 3 units to the right. We go over 1, up 1 here, over 1, up 1 here, and then we still go over 2, up 1, 2, 3, 4, and there's our new parabola. We've just shifted it 3 units to the right. Now this one, when we shift it to the right, we need to, inside of this parenthesis here, we need to subtract a number to make it go right. So subtract a number I can't spell. Subtract a number from x in the parenthesis. And that moves it 3 units to the right. I had to move so that the lights wouldn't turn off on us. All right, so next one. Now I want to go the opposite direction. I want to go 3 units to the left instead. All right, so looking at Desmos, if I want to go to the left, well, minus 3 made it go to the left. So let's see if plus 3 makes it go to the right. And it does. So there it goes, 3 units to the right. So plus 3 makes it go left. Minus 3 makes it go right. It's kind of the opposite of what you think it would do. So going back here, so if I wanted to go to the left, ooh, wait, I missed something. And make it narrower. So when we were making it narrower, remember we put a number in front of the x squared. So let's put a number over here and let's make it narrower. Remember this number had to be bigger to make it narrower. So let's make it 2. And there it goes. It's narrower now. So 2 pulls it back in together. And now I've got it narrower and it's been moved to the left 3. I was not reading. All right, so our function that we did was f of x equals 2 times the quantity x plus 3, because we're going left, squared. So this moved our vertex left 1, 2, and 3. We also were making it narrower. So when I go over 1, normally I go up 1 on the parent function, but since I'm multiplying by 2, I'm going to go up 2 instead. Normally if I went over 2, I'd go up 4 on the parent function, but we're doubling it here, so I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, and 8 right there. And there's our new parabola. It is 3 units to the left, and it's narrower. Oh, I forgot to change this. This is supposed to be to the left. So to translate to the left, we add a number to x in the parentheses. All right, almost there. Last part. All right, vertex or graphing form of a parabola. So this is what we're kind of leading up to. The formula for a vertex form is f of x equals a times the quantity x minus h squared plus k. The a value, remember, was that strength that controls if it faces up or down. So if it opens up, we're going to have a positive a value. If it opens down, we're going to have a negative a value. Also, the a affects how narrow or wide it is. If we have a number bigger than 1 in the a, it's going to be narrow. If we have a fraction like 1/2 or something, it's going to make it wider there. So that's what the a value does. It makes it face up or down and makes it narrow or wide when we compare it to the parent function. The h and k are the coordinates of the vertex. So we saw on those last couple ones how to move it side to side or up and down. The k moves it up and down. It's going to be the y coordinate of our vertex. The h, remember, it was always doing the opposite. When we wanted to go to the right, we subtracted a number. When we wanted to go to the left, we added a number. So it's always going to be the opposite of this value here for the x value of our vertex. So looking at this next one, what is the vertex of this equation? Well, this is my h, and I take the opposite of it. So 5 should be the x coordinate of my vertex because I'm going to take the opposite, and then plus 7. So 5, 7 would be my vertex. And we can check that answer in Desmos if we want just by plugging it in. We're not going to do that. All right, next, write the equation of a quadratic function with a vertex at -2, 3. It opens up, and it's narrower than the parent function. All right, so first of all, it opens up. That means the a value is going to be positive. and it's narrower. Narrower means that that value has to be bigger than 1, so let's just put 2 there. Okay, our vertex is at -2. Now remember, it's always the opposite of this x value. So here I'm going to do, instead of x minus 2, I'm going to do x plus 2. Because remember, a plus moves it to the left instead of moving it to the right like we think it should. And then 3 is the y value, so to move it up, we would add 3 there. And there's the equation of that parabola. All right, now we just got 4 problems where we're going to make the equations just from looking at the parabolas. Here I've got a vertex. The vertex is at 1, 0. Okay, and when I go over 1, I go down 1. So it looks like my a value is just -1 because it's still going over 1, down 1, over 2, down 4. So it looks like it's still doing that same pattern as the parent function, but this one faces down, so we need a negative a value. So my equation for this one would be y equals negative x minus 1, because remember we go opposite of this direction, so x minus 1 squared. There's its equation. Next one, the vertex is at 0, -5. So my vertex is at 0, -5. This one opens up, so my a value is positive. And then when I go over 1, I don't go up 1. It looks like when I go over 1, I go up a half. Let's check when I go over 2. When I go over 2, I don't go up 4. I only go up 1. Ooh, so it's not a half. When I go over 3, I go up 1, 2, 2. Huh. So it looks like this is 1/4. Because when I went over 2, instead of going up 4, I only went up 1. That's 1/4 of the distance I should have gone. So it looks like my equation here should be y equals 1/4. Now there is no movement side to side. So in, way up here, in our formula here, the h value is just 0. So I don't need a parenthesis there. It's just going to be x squared. And then it shifts down 4, so -4. All right, next one. This one's facing up, so the a value is positive. When I go over 1, I go up 1. So it looks like a is just a 1. So it's just the same as the parent function there. But my vertex is at 2, -2. So my equation is going to be y equals, I went 2 to the right, so I do need to put -2 here, squared, and then I went down 2, so we put a -2 outside, and there's our equation. For this one, looks like my vertex is at 1, 2, 3, 4, -4, 1. My a value has to be negative because it's facing down. And when I go over 1, I'm going down 1, 2. When I go over 2, I'm going down 1, 2, 3, 4, 5, 6, 7, 8. I'm doubling the amount that I should have gone. So my a value is -2 for that one. So our equation would be y equals -2 on the outside. And then we do the opposite of this one. So x plus 4 squared and then plus 1 because it shifted up 1. And there's your notes. We're all done. All right, math hard. See you later. Bye.